Right, so we are on page 12. So we talked about this yesterday, that system of equation, you could solve it the algebraic way, which we learned in chapter 3, and you also learned it a long time ago in Algebra 1. Yesterday, we learned how to solve it by matrix, and then I said there were two ways. First one is the inverse matrix, which you did your homework on. The second one is called row operation, and this is a little bit tricky, and that's why we're going to take 2 days to do it. Okay, first of all, we have to take these system of equation and write it as a matrix, but we are not going to write it this way. This is only for inverse matrix. This needs to be written in a different way, and this is how you do it. First of all, they still need to be in ax plus by equals c. Okay, so that's the standard. Everything has to be in ax plus by equals c, or else you are not going to be able to solve it. Next, the way you write the matrix is one big matrix. In inverse matrix, there were 3 matrices, but in this form or this method, you only have one big matrix. And it's very easy to write the matrix. All you do is take all of the numbers and then write it into the matrix. For example, first equation, x plus 3y equals 7 becomes 1, 3, 7. Okay, so just take the numbers. The second equation, 3x plus y equals negative 8 becomes 3, 1, minus 8. Okay, and then what I like to do is I like to indicate where the equal sign was. So I put a line here that tells me that was where the equal sign was. Okay, so just to help you remember this later, this is where all the x's are. This is the y. This is the constant. And then this was that equal sign. Your book is probably not going to write it the same way I do with that line because I guess they don't like to do it. But it keeps me, it reminds me where that equal sign is because it gets really crazy if we don't. Okay, so let's go ahead and have you guys practice. Did you guys finish copying yet? Okay, so you're going to practice. This time you have 3 variables, x, y, z, but put it in standard form. X, y, z equals constant. And then rewrite this as a whole one big matrix. All right, let's double check. So the first equation is already in the correct form. Second one is. Now, if you're thinking, where is the y? There is no y. So then that means it's a x plus 0y. Plus 3z equals 12. So then when you put it in the matrix, please make sure you put a 0. The last one is not in the correct form. We need to move x. So that's 5x plus y. Since there is no z, it's a 0z equals 1. Okay, if the variable is missing, you put a 0. So then this becomes 1, I'm sorry, not 1. I'm not looking at it. Oh, yeah. 1, negative 3, 1, 6. 1, 0, 3, 12, and 5, 1, 0, 1. Good? Okay, let's try one more. Let me know when you're done so I can double check. All right, so this becomes 4, 0, 2, 8, 0, 1, 5, 20, 2, 1, 0, 7. All right. Now, let's practice one more kind. We are going to go back from a matrix into equations. Okay, so kind of just going backwards. So just to recall, this part is x, this part is y, and this is the constant. And then the line is that equal sign. Stephanie, do you have a question? No? Oh, okay. Okay, so for example, this first one, this first row, 5, 2, 7 becomes 5x plus 2y equals 7. Okay, the second row, 0, 1, 9. 0 means that there is no x, so you don't even have to put anything. It's just a y equals 9. Okay, so that's how you go backwards. All right, let's have you guys try one. 2x equals 6, and then 5x minus 2y equals 1. All right, let's get ready for our solving. Okay, so when we are using row operation to solve, our goal is to make the final matrix look like the diagonal matrix or the identity matrix. Okay, so the diagonal matrix is what we want. Okay, that means, I don't know if you can read my writing, diagonal matrix. So what we want to do is eventually we want to change the matrix so it looks like 1, 0, 0, 1. Okay, and on the right-hand side, it's going to have an A, B, or whatever that number is. It doesn't really matter. Recall that this column is X. This column is Y. This is my equal sign, and then this is the constant. When we read it over, it means X equals A, Y equals B. So this is how we solve. Okay, we want to get into this form so that we can figure out what each variable is equal to. Okay, for example, X, Y, Z kind. When we have 3 variables, it becomes X equals A, Y equals B, Z equals C. So this is what we want to do. Once we can get it into this form, we have the answers, okay? But this game is a little bit tricky. It has some rules. So just think of it as like I'm teaching you a new game. The game has rules. You just follow the rules. And then don't ask a lot of why in the beginning. But once you get used to the game, you understand why the game has to be played this way. Okay, so in the beginning, you're like, what? This makes no sense. It's okay. Just follow the game rules, and then eventually it makes sense. Okay, so we are going to use row operations. Row operations. And there are some rules. First, when you have a matrix, you can switch any 2 rows. So for example, if you have this matrix that has these 2 rows, we can swap them entirely, and that becomes, so I'm going to switch row 1 and row 2, so it becomes -1, 4, -4, 1, 5, to -3, 4. So that's the first rule. You can't switch rows to make it look like the way you want. Okay. When you switch rows, please make sure you switch the entire row. That's the first one. Second one, you can multiply a row by a constant. So for example, let's say that I don't like this row the way it is. I want to multiply by 2. I can. And then I can do that only to that row. I don't have to multiply to the entire matrix. And that is okay as well. So that is 4, -6, 16. And then keep the second row the way it is. Yeah.
If you want to multiply the second row.
Oh, did I multiply wrong? Sorry. Yeah. Mm-hmm.
If you would multiply for the second one, do you write -4? Like, do you multiply -4 to the entire row?
No, so multiplying by constant means that you can multiply any row by just one number and then don't do that to any other rows. And that's okay.
But does the number matter?
Right now, I'm just kind of telling you a strategy, but you would strategically choose what number you want to multiply. And I'll tell you that later. Yeah.
So once you multiply one row by one number, you're done for that matrix, right? You can't multiply another row.
You can keep multiplying any number you want.
Okay, so each row can be multiplied by once.
Yes, correct. All right, and then last rule is you can add, okay, this one is a little bit tricky. People always get confused. You can add one row to another row and replace that row. Okay, it gets really crazy. So let's call this row 1, let's call this row 2. We can take row 1 plus row 2 and then replace row 2. So I can replace an entire row. So row 1 was 2, -3, 4. Okay, row 2 is -4, 1, 5. And what I'm going to do is I'm going to add them together. So this, I'm writing out this operation. I'm going to take row 1 plus row 2. And then whatever I get, I'm going to replace row 2. So here I am taking row 1 and row 2. I'm going to add straight down. So this is -2, -2, 9. And then what I'm going to do now is replace row 2. So replacing row 2 means row 1 is not changing, so that is 2, -3, 4 still. Row 2 now becomes -2, -2, 9. Okay? All right, so that's the third rule or the third strategy. And these are 3 things that you can do, and you can actually do all 3 of them at the same time if you want. So that's another strategy. But anyways, let's solve a problem with you. Yeah?
Can we only replace row 2 or can we replace row 1?
You can replace row 1. You can replace any row. Yeah. All right. Let's try solving this. First, change it into matrix form in the row operation so that we can solve. All right, and then we probably want to put it on the left because this is going to take a lot of space. All right, so just a reminder. What we want to do is eventually make it look like 1001 with some numbers on the right. Okay, 1001. So that's the goal. Okay, so looking at this matrix right now, let's kind of do a matching and see if we are kind of there. I want a 1. I do have a 1. Okay, so we're good, right? Okay, the next thing I want to do is I want to do this in order, and then I have an order to this. Because when I was in high school, I had to do this, and then I don't think the teacher taught us how to do this in order. He just said, you know, get it into 1001, so I did everything I could, and sometimes the homework took too long, and then I realized there was a specific way I had to do it. If I don't do it that way, it would just take a long time. So then I realized to get this into the right form, the fastest way is to go like this. Okay? So 1, 0, and then 0, 1, or actually, sorry, 1, 0, and then 1, 0. You always want to get the 1 first. And then there's a reason for that. And then that will make this faster. Okay, so we have the 1. We're going to make this 0, which is this 2. I don't want this 2. I want it to make it into a 0. Do not multiply by 0. If you multiply by 0, the whole thing is 0. It makes no sense. So don't make it into 0. Here's what you do. You use the first row to make it into a 0. Okay, so you ask yourself, I want this 2 to become a 0. What number should I add to 2 to make 2 a 0? -2. Okay, so where am I going to get the -2? I am going to get it from the first row. So if I multiply the first row by a -2, and then add to that second row, replace the second row, it becomes a 0. Okay, that's a lot. Okay, so let me write this step out for you. -2 times row 1 plus row 2, replace row 2. So maybe in the first few homework assignments or problems, you might want to write out your steps so you don't mess up. And also, just like matrix, you know, we've been doing for like 3 days, it's easy to make calculation errors, so please use calculator. Okay, so -2 times the first row. All right, -2 times the first row plus the second row. Okay, I'm going to do this kind of slow in the beginning. So -2 times the first row, that's -2, -8, 2, plus the second row. Second row is 2, 5, 4. Add that together, 0, -3, 6. And then I'm going to replace row 2. 0, -3, 6. All right, let's review a little bit. The reason we're doing this is I want this 2 to become a 0. To make it a 0, I need to use this 1 and then add it to become a 0. So I need to multiply row 1 by -2. Okay, row 1 by -2, add it together. I get this row, and then I replace row 2. Good? Okay, let's do the next one. So remember I said there was a specific order. I go 1, 0, 1, 0. Okay, so this -3. how do I make this negative 3 into a 1?
Multiply by negative 1/3.
Yes, multiply by negative 1/3. So what we want to do to make anything into 1 is almost like dividing by itself. Okay, that would be the fastest way to make it into a 1. So we are going to multiply by 1/3 to row 2 and then replace row 2. Okay, 1, 4, negative 1. This is easy to kind of do it in your head, so I'm going to do it in my head. So 0, 1, and then 6 times negative 1/3 is negative 2. Good? The last thing we want to do is make this 4 into a 0. How do we do that? We have to use this 1 to help it become 0. Huh? Yep, multiply by negative 4, and then add it to the first row and replace the first row. Yeah. Okay, so we are going to multiply negative 4 to row 2, add it to row 1, and then replace row 1. Okay, negative 4 times row 2, add to row 1. All right, so let's do that. So negative, no, that's a 0. Okay, negative 4, 8, 1, 4, negative 1, added together, 1, 0, 7. Replace row 1. 1, 0, 7, 0, 1, negative 2. Done. Okay, what does this answer mean? It means x is 7, y is minus 2. Okay, you have to write that at the end. If you don't, you have to tell me which matrix was what. Anyways, you gotta have some kind of thing that tells me what the solution is. All right, let's try another one. This one's a little bit easier because the numbers are smaller. All right, go ahead and set up your matrix first. Okay, once you set up your matrix, it should look like 3, 5, 0, 1, 1, 2. Okay, remember you want it to look like 1, 0, 0, 1. So what should we do first? No, actually we want this to be a 1. We want to get that to be a 1 first. You can multiply by 1/3, but remember there's one other thing you can do. Basically just switch row 1 and row 2. Right? We automatically have a 1. So you don't really have to do a lot to get that 1. Okay, now that 1 is done, how do we get this 3 to become a 0? Multiply first one by negative 3, add to row 2, replace row 2. Okay, I'm gonna do the multiplication in my head. So negative 3, negative 3, negative 6, 3, 5, 0, 0, 2, negative 6. Replace row 2. 1, 1, 2, 0, 2, negative 6. Okay, 1, 0 is done. We're now going to get that 2 to become a 1. Multiply by 1/2. Good. 1, 1, 2, 0, 1, negative 3. All right, I'm going to let you do the last step. All right, the last step we're going to do is basically, if you think about it, this is essentially what we're doing. Row 1 minus row 2, replace row 1. 1, 1, 2. Minus row 2 means take all those numbers and make it negative. So 1, 0, 5. And then replace row 1, so 1, 0, 5, 0, 1, negative 3. That means A is 5, B is negative 3.